All right, so good afternoon. So today we're looking at solving exponential equations using common base. So first thing you want to know is what is a common base, okay, and how to do this. So your basic steps are going to be to write a common base. And common base basically says you want the same base number. So if you had, for example, 2 to the x power, this 2 is a base number, okay, that's your base. So when we say common base, it means we want to make sure that the equation we're solving have the same base number in order to be able to solve it. Okay. Then once we do that, we're going to simplify down any exponentials that we need to, such as negative exponents and distributions, things of that nature. Then once we have common bases, we're going to do something called, or essentially we're just going to drop the base of what's going to happen. And then, so therefore, whatever the equation is on x is going to be the same as equal to y. And then we're going to solve it. And that's pretty much what solving an exponential equation with a common base does. Okay, so here's kind of what you're looking at. So if I had 3 to the 2x minus 9 is equal to 3 to the 7th, excuse me. First thing you notice the fact that they both have a base of 3. And since they both have a base of 3, we're just going to drop the base, get rid of it completely, and our exponents become, minus 9, the equation we're going to solve. Then we do a little bit of algebra here, 16, and we figure out that x is equal to 8. Okay, that's it. That's what I mean by that. Okay. Here we have a base E equation. We have a base E equation. Since we have base E equations and it's a common base, we can drop the base. So whatever we have becomes our equations. And this is what we're actually going to solve. So again, I'm going to do this a little differently, where if I do 2 plus 2w to both sides, that's 6w. So add 1, that's 6. So that w is equal to 1. Okay. That's pretty much it. Okay. So what happens when you have multiple bases? This is where the exponent rules kind of come into play. So rule of exponents, and it's kind of like if we know we're adding, if we're multiplying the common bases, we're essentially adding exponents. That's all we're doing. So since there's a common base of 5 across, this is going to essentially become c minus 1 plus 3c plus 2 is equal to 7c plus 16. Combine, this is a c, not an x. Combine some like terms. So 4c plus 1 is equal to 7c plus 16. Again, do a little bit of algebra. So that c has to be equal to negative 5. Okay? Now the other part of this is how do you make a common base? This is where you actually have to know your exponents, know your power rules, things of that nature. If not, use a calculator. But here's what I mean by that. This is the base of 9. This is an 81. I need to change this 81 to a base of 9. So you have to know that essentially the same thing as 81 is 9 squared. So 9 squared is 81. So you have to know your power rules. You have to know your powers for your values. Then your bases are the same, common base. You can get rid of them. Set it equal to your exponents again. And again, do a little bit of algebra. So that you get that y has to be equal to 7. Okay. Same thing with fractions. You have to know your bases. So for example, we know the basis here is 4. So what base will give you a 64? 4 to what power will give you a 64? And again, if you know your exponents, 4 to the 3rd power is 64. But because it's a 1 over 64, this is the same thing as 4 to the negative 3 power. just like that. And again, we follow the same rules. Then do a little bit of algebra. Square root is how you get rid of square root, squareds, a squared. And anytime you square root, what you have to know is the fact that you want to plus, oops, not an a, plus or minus the value. In this case, the value being 1. Okay. Again, 2 is my base. So 2 to what power is 32? And again, if you guessed 5, or if you know that it's 5, great. So when you have a term that's already sitting there, you want to make sure that that 5 is going to get distributed into everything inside. Okay, so you have m minus 9 is equal to 5m plus 15. And then you can, do some algebra. And that's going to be, oh my God, negative 24. I can't think for a second there. Okay, so that m has to be equal to a negative 6. So that's what we talk about when we solve the equation with common bases. That's essentially what we're looking at. Okay. I'm going to run through some more. I may not do a whole lot of talking at this point. But in this case, so here's one that you kind of, so here you see how there's a 49 and a 343. 49 is not does not have a base to 343, so it actually has a common base that you have to know. And again, this is where you have to know your power. So for example, I know that 49 is the same thing as 7 squared, and since it's a fraction, I know that it'll be a negative 2. Therefore, 7 to what power is 343, which is 7 cubed. And again, if you're not sure, use your calculator. Common base, distribute. So 6n minus 12 is equal to negative 2n minus 8 plus 2n. Okay. Plus 12. So 8n is equal to, what is that, 4? Yeah. Divided by 8, so n is 1/2. And again, I'm going to just keep kind of working through these at this point, kind of show you. 9 and 243, 9 and no power gives me that. But 3 squared will give me 9, so I'll make this 3 squared is equal to 3 to what power is 243. Again, use your calculator if you're not sure. Should be 3 to the 5th. Because 3 to the 4th is 81, so 3 to the 5th is, yeah. Common base. So P is equal to, divided by 6 would be 5 over 2, so negative 5/2. Okay. See, 36, and 216. Well, 36 is 6 squared. So 6 squared 2r times 6 to the negative 2, because it's 1 over 36 is a negative exponent. And in 216 is 6 to the 3rd. I know that. Again, with multiplying, you're essentially adding exponents. So this becomes 4r minus 2 is equal to 3. And then do some addition or some algebra. So r is equal to 5/4. Let's see. 4 squared, 4 to the 3rd, but 4 will not give me 32, so it's not 4. So I'm going to go to base 2 instead. So 2 to the 4th power is 16, so negative. So 2 to the negative 4th power here. 2 to the power 64. 5 is 32, I know that much. So 2 to the negative fifth times 4. And if 5 is 32, I bet you 2 to the sixth, therefore, is 64. And again, if you're not sure, folks, use your calculator. So negative 4x plus 7, and again, since we're multiplying, plus 6x plus 30 is equal to negative 20. Combine some like terms, so 2x plus 37. Hold on. No. This is not 7. This is 28. My fault. I forgot to distribute all the way through. That's 58. No, this is minus 28. So that'll be plus 2 is equal to negative 20. I'm going to do some algebra. So x is equal to negative 11. So that's how you solve common base exponentials when it's all said and done. Okay? There you have it.